Hello there. This week we're going to go through volume, okay? And we're going to go through volume of prisms, cylinders, pyramids, cones, and spheres. Okay, so the key thing with volume, we're using these three formulas right here, okay? With volume, if you look, for prisms and cylinders, okay, its volume is big B times H. Remember, big B is area of the base, okay, and then H is the height of the prism, or the height of the cylinder, or the height of the pyramid, or the height of the cone, okay, so it's going to be the height of the solid. So you have to be careful, just like in surface area. Let's say we have a triangular prism, okay, and then I'm going to draw these dashed lines. Okay guys, dashed lines are lines that you can't see, but they show you that it's 3D, okay? So this is our triangular prism. Remember, your prisms are named after the shape of their bases, as are the pyramids, okay? And then a cylinder and a cone, they both have a circle as their bases. So for a prism, okay, and a cylinder, remember the height is the distance between the two bases. So on a triangular prism, the shape of the base is going to be this triangle, okay, because it's a triangular prism. Now, in order to find the height of this prism, well, I find, okay, here's one triangle, here's my other triangle at the back of it, the distance between the two, that is the height, okay? And you have to be careful to not confuse the height of the prism with any kind of like height that you might use to figure out the area of this triangle, okay? So just keep that straight. Just whenever I'm talking about the height of the prism, it's the distance between the two bases, okay? And then we'll get into more detail with the pyramid and the cone. So for right now, let's go to our first problem. Okay, it says find the volume of each figure. Round your answers to the nearest tenth if necessary. So this first one we have is a rectangular prism. On a rectangular prism, it doesn't matter which side you use as the base, you just have to use its matching one to figure out that height. So I'm going to use this top one right here. I'm going to call that my base. Okay, so there's the base. So for the volume of a rectangular prism, it's area of the base times the height. So first thing I have to calculate is the area of this rectangle. So for a rectangular prism, and I'm only concentrating on the rectangle alone, okay, rectangle alone, it would be base times height. So you see this h here is not the same h as in the general formula. So this h is talking about the height of this rectangle only. So it's 9 times 4, which is 36. So the area of this rectangle here is 36. Now I can talk about the height of that prism. Okay, remember I said the bases using this top rectangle, and its match is this one here on the bottom. Now the height of the prism is the distance between the two. Okay, the height of the prism is this 4 right there. Okay, so height of the prism is 4. So the volume of this prism is going to be the area of the base, which we figured out was 36, times the height of the prism, which is 4. So 36 times 4, and you will get 144. Alright, next one. This is a triangular prism. Again, think about the name of the shape. Triangular prism. So what shape is the base? A triangle. So we need to look on here and we need to find the triangle. Okay, well, triangle right there. As you can see back here, there's a right angle, so here's our right angle. So this is the shape of that base. It's a right triangle, and this side right here is 3. This here, this is 4, and then this side is 5. Now, again, for the volume, it's going to be area of the base times the height. Okay? I'm talking about the area of this triangle right now. Okay? So for big B, well, if you go back to look at our formula chart, you find the formula for the area of a triangle. What's the formula for the area of a triangle? A equals 1/2 base times height. Okay, so let's go back here. So right now I'm concentrating only on the triangle. Okay, and remember your base and your height are at a right angle to each other. So which two sides of the triangle are connected to this right angle? Which one is making that L? The 3 and the 4. So this would be B, that would be H. So you have 1/2 times 3 times 4. So put this in your calculator. 3 times 4 is 12 times 1/2, so it's going to be 6. So the area of the base is 6. Now we'll go and we're going to talk about the height. Okay, again, remember, the bases are these two triangles. Okay, the one on the front, back here. It's a little bit easier to see for you guys. Triangle on the front. And then the triangle on the back. Okay, those are the bases. Now the height of the triangle is the distance between the two. So this short little piece that's connecting the two triangles, that's your height. See, it's 2. So that's the height of our prism. So to find the volume, we're going to do area of the base, which we figured was 6, times the height, which is 2. So 6 times 2, 12. And it would be inches cubed. Okay? Because volume is in 3 dimensions, so that's why it's inches cubed. Okay, next one. Here we have a pyramid. Alright, this one, and I'm doing 2 pyramids so you can kind of see that what we're doing is going to be the same. Doesn't matter about these measurements down here. This one is a square pyramid because it's 2 inches and 2 inches there. This problem right here is going to be a rectangular pyramid because one side is 5 and the other side is 6. But it doesn't matter whether it's a square on the bottom or a rectangle on the bottom. We're going to do the same process. So for a pyramid, volume is 1/3 big B times H. Remember, big B is area of the base. Okay, we're dealing with rectangles on the bottom. Remember, the area of a rectangle is base times height, or some people like to say length times width. Okay? Length times width. So look at your base, the rectangle on the bottom. Okay, what's the length and the width of it? Well, here it's 2, 2. So 2 times 2. The area base, 2 times 2 is 4. Now, the height, your height of your pyramid is always going to be this line in the middle. Okay, so this line going up and down, I know it happens to be 2 on this one. That's the height of our pyramid. So now the volume of our pyramid is 1/3 times, now what was the area of the base? 4, times the height, which we figured out was 2. I'm going to tell you how I'm typing this, like how I'm saying it is how I'm typing it in my calculator on my phone. So I do 1 divided by 3, and I don't press enter or anything like that, just do 1 divided by 3 times 4 times 2. So in your phone's calculator, you should see a 1, a division symbol, a 3, times, a 4, a times, and a 2. But you got that, now you press enter. And you get 2.6 repeating on and on and on, okay? You only need to look at the second number. See how it's a 6? It's going to make that first 6 here, the one to the left, round up. So it's going to be 2.7, which is cubed. Okay, our next one that we have, this is also a pyramid. So we still have to do volume is 1/3 area of the base times the height. Okay. Let me do this in red. Volume is 1 area of the base times the height. So the area of our base. Here's our base. It's this rectangle. How do you find the area of a rectangle? Base times height, aka length times width. So you have 5 times 6, which is 30. Now we need the height of our pyramid, which is this line going straight up in the middle. You can know the height because they're going to point to it, okay? So this is our height. So the height of our pyramid is 9. And now the volume. 1/3 times the area of the base, which was 30, times the height, which is 9. So 1 divided by 3 times 30 times 9, and press enter. Divided by 3 times 30 times 9, press enter, and we get 90. It's inches cubed. Okay, just remember on the quiz, don't type in the units, just the number. Alright, next thing we have here is a cylinder. So let's go look back at our formula chart. Okay, volume of a cylinder, look over here. It's area of the base times the height. Alright, oh, but let's go back. Let's think about this. A cylinder, what shape is the base of a cylinder? Well, it's a circle. Okay, so we need the area of a circle, which is pi r squared. So for our cylinder, volume is area of the base times the height. For the area of the base, we have to think, okay, what shape is our base? It's a circle. So it's pi r squared. Okay? Pi r squared. R is the radius. The radius is only halfway across. So it's going to be pi times 1 squared. Alright, now I'm going to work this problem out 2 ways. The first one, I'm going to leave it in terms of pi because some questions will ask you that. And then I'm going to continue on and put it in tenths, rounding to the tenths, because some questions might ask you like that. Okay, so we have here, and this is a good thing you're going to do for all of them. Just do the number right here, do the radius squared. So guys, 1 squared, that's 1 times 1. So it's just 1. So it's 1 pi. And then now the height of our cylinder is 1. Okay, so volume is going to be area of the base, which was 1 pi times the height, which is 1. So we just do 1 times 1, well that's 1, and then the pi comes along for the ride. So the volume of this cylinder is 1 pi, also known as just pi, because you don't have to put the 1 in front. Like same thing, like 1x equals to just x. Okay, same thing here. 1 pi is just pi. So there it is in terms of pi. But let's say I want it rounded to the 10th. Well, I would do 1 pi times 1, and then I would just type all of this in the calculator. 1 times pi times 1, and that would give me 3.14159. If I need to round it to the tenths, so I have to look at this second place here. It's a 4. It's not going to make it round up, so it's just 3.1 centimeters cubed. Okay. Alright, now let's go over here. This is a cone. Okay, a cone and a pyramid, same formula. E is equal to 1/3 area of the base times the height. The only only difference here is that our base on a cone is a circle. So we have to do pi r squared. Okay, pay attention. See this line is going all the way across? That's our diameter. So to get the radius, they give you the diameter, you have to take your radius, or I'm sorry, if they give you the diameter, you have to take the diameter and divide it by 2 in order to get the radius. So all the way across is 8, so halfway across would just be 4. Okay, so our radius is 4. So pi times 4 squared. So all I'm doing is just going to do 4 squared. 4 times 4 is 16. So it's 16 pi. Okay. Now the height of our cone is from the point to the center. It's also 8. So now our volume. It's 1/3 times the area of the base, which was 16 pi, times the height, which is 8. Now if I want to leave this in terms of pi, I'm going to type everything in the calculator except for pi. So I would do 1 divided by 3 times 16 times 8. So that gives me 42.6 repeating. Okay, just look at the second one. It's a 6. So it's going to be 42.7. And you got to put pi in the end. Okay, so 42.7 pi. So that's in terms of pi. Now if I want this rounded to the nearest tenth, well, I just do 42.7 and multiply it by pi. And make sure that you are using the pi symbol in the calculator. So I get 134.1. Okay? So there you go. Alright. Now we have one last shape that we have to learn how to find the volume of. So we're going to go back to our formula chart because our last shape is a sphere. Okay, for a sphere, the volume is 4/3 pi r cubed. Okay, it's very important that you don't forget to do the r cubed. Okay, if you mess up on that part, your answer is going to be off by a little bit. So it's 4/3 times pi r cubed. So only thing you need to know about a sphere is its radius. So it's 4/3 pi r cubed. The radius on here is 8. So we're just going to plug in 4/3 times pi times 8 cubed. Okay. Now to remember and listen to how I'm typing this in the calculator. And I'm doing this on my phone, so most of you guys have your phone calculators. Just type in as I'm doing. So 4 divided by 3 times pi times 8, and then I have to get the power button. Mine looks like x with an exponent of y, and put 3. That's how it looks on my calculator on my phone. So I type that in, 4 divided by 3 times pi times 8 to the power of 3. And I press enter, get 2,144.660 on and on. In order to round to the tenths, I only need to look at the second number. It's a 6, so it's going to make this first number go up by 1. So 2,144.7. That would be centimeters cubed. Alright. And again, if you wanted that in terms of pi, you just type everything in the calculator except for pi. That would be your answer. You just put pi on the end. Okay. Now, before we get to these last set of problems, okay, we need to go through a couple of things because you can see here they're saying, okay, we've got this flower box and it can have 32 flowers in it. How many flowers can you have in a box that's 5 times that size? It's not as simple as taking how many flowers and multiplying it by 5. Okay? We've got some extra things we have to consider. So we're going to add in a page here. Alright, we're doing dimensional change. So this would be a good time maybe to take a break, come back. Don't try to watch the video all at once. Okay, so dimensional change. So there are 3 dimensions that can change when we're talking about changing the size of figures. You can have a change in the figure's perimeter. You can have a change in the perimeter's area if it's just 2D, or the surface area if it's 3D. And then you can also have a change in its volume if it's 3D as well. Okay? So first thing, we're going to talk about perimeter. How is perimeter affected by dimensional change? I'm going to give an example here. Let's say we have a little square. Okay, each side of our square is going to be 2. Okay, so the perimeter of our square, we just take the 4 sides and add it up. 2 plus 2 plus 2 plus 2. Okay, that's 8. Alright, now let's say that we want to enlarge this square by a scale factor of 5. Okay, that means that each side of this square is going to be multiplied by 5. So now instead of being 2 by 2 by 2, 2, you have to do 2 times 5, which is 10. 2 times 5, 10. 2 times 5, 10. 2 times 5, 10. So now the sides of our square are 5 times as big. Well, what does that mean about the perimeter? Let's look at it up. So now, perimeter, you just add the 4 sides, 1, 2, 3, 4, and they're each 10. It's 40. So look, how do you go from 8 to 40? Well, you take your original perimeter, and what would we multiply that by in order to get 40, the new perimeter? Well, 8 times 5. And what was 5? Scale factor. Okay, so perimeter, you multiply by the scale factor. So see, they gave us the original perimeter. They told us our scale factor was 5. We would just do 8 times 5 and we get 40. Okay? I used the pictures to help show you guys what was going on. But just if you're changing the perimeter, you multiply it by the scale factor. Now area is going to be a little bit different. Let's keep our same 2 squares as area, and this also applies to surface area. Okay, think about area. Think about the units on area. They're not just, inches or centimeters or whatever. They are inches squared or centimeters squared. Okay? The important thing there is squared. So we have our original square. It's 2 on each side. How do you find the area of a square? You do length times width. 2 times 2, which is 4. Okay, so the original area is 4. Now again, we set our scale factor. It's going to be 5. So that means the sides are going to get 5 times as big. So they go from being 2 to being 10 on each side. Well, now how about the area? Area, it would be 10 times 10, which is 100. If you take 4 and you multiply it by 5, do you get 100? Mm-mm. You have to do 4, which is your original area. And you're going to multiply 4 times what? 4 times 25, right? 25. Where do I get 25 from? Look at your scale factor. 25 is 5 squared. So in order to find the new area, okay, you have to take your original area and you multiply it by the scale factor squared. So you multiply scale factor squared, okay? And again, we're going to do examples with this, but just you take your original area, you take whatever your scale factor is, you raise it to the second power, that's squaring, okay? It's 5 squared, that means 5 times 5 is 25. You multiply those together and you will get the new area. Now the last thing that we have is with volume. So think about it. Perimeter, you just multiplied by the scale factor. Area, you multiplied by the square of the scale factor. So volume, think about the units for volume. They're inches cubed, centimeters cubed. So maybe I might be multiplying by the cube of the scale factor. So let's see. I'm going to go with a rectangular prism here. Okay, I'm going to say it's 3 by 4 by 5. Okay, 3 by 4 by 5. I'm going to say the scale factor is going to be 3. Okay, it's going to be 3. So my original volume here, well, I would do the area of the base, so I'm going to do 3 times 4, that's 12, and then I got to do times the height, so times 5. So 3 times 4 is 12, times 5, 60. Okay, my original volume, 60. Now, let's go over here, and I'm going to have my cube again. This time, the dimensions are going to be blown up by a scale factor of 3, so they're going to be 3 times as large. So this 3 down here is going to become a 9. The 4 is going to become a 12, and the 5 is going to become a 15. So now the volume, 9 times 12 times the 15, it's 1,620. Certainly if I take 60 and I multiply it by 3, I'm not going to get 1,620. Okay, let's figure this out. Let's do 1,620 and divide it by 60. Get 27. So I had to do 60 times 27 to get the 1,620. 60 was my original volume. 27. That's got to deal with our scale factor. Let's think about it. Okay, 3 is just the scale factor. 3 squared, which is 9, that's the scale factor squared. 3 cubed, which is 3 times 3 times 3, that's 27. So that's where we get that. It's the scale factor, which was 3, raised to the 3rd power. Okay? So that's the scale factor cubed. Okay? And then this is our new. So volume, to get the new volume, have to multiply by the scale factor cubed. Okay, so like a summary down here. Perimeter, just do the original perimeter times the scale factor. Okay? Area, we're going to do the area times the scale factor squared. And volume, we're going to do the volume times the scale factor cubed. Okay? Because think about it, the units. Okay, units for perimeter would just be like inches. Units for area would be inches squared. Units for volume is inches cubed. So you can kind of keep track of it like that. Whatever the units are, that's the exponent you put on the scale factor. So let's go back to our problems here. So it says, a 2 foot by 2 foot flower box can have 32 flowers in it to ensure optimal growth. How many flowers can be grown in a box that has dimensions 5 times the size? So, we have a 2 foot by 2 foot box, and that's 32 flowers. Okay, and we're dealing with area. 2 by 2, so the area is 4. Okay? Now, we're going to get a box that's going to be 5 times that size. So it's 10 by 10. Think about it. How many times can you fit 2 into 10? You can fit it 5 times. So I have 5 going this way, and then I'll have 5 boxes going this way. And now, each of these little tiny boxes is one of these 2 foot by 2 foot. So let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So now I have 25 of these little 2 by 2 boxes. Where did I get 25? What's 5 squared? Because we're dealing with area. So what's 5 squared? It's 25. And each box, each 2 foot by 2 foot box can hold 32 flowers. So I do 32, the original amount, times, and since I'm dealing with area, my scale factor squared. So 32 times this 5 squared, which is 25, and I'll get 800 flowers. Okay, next one. So be careful. We didn't just increase it 5 times the amount. We had to do it 5 squared because we're dealing with area. So now this one, it says a rectangular prism. Okay, it's a prism, so that means it's 3D. Okay, so we're talking about surface area, we're talking about volume here. It says the dimensions are reduced to 1/4 of their original, so that's our scale factor. It's 1/4. And it says how many times smaller is the surface area and how many times smaller is the volume. Okay, surface area. Remember, how does area change? With the scale factor squared. So you take our scale factor, 1/4, and we're going to square it. And that means you do 1/4 times 1/4. So 1 times 1, which is 1, over 4 times 4, which is 16. So the surface area is going to be 1/16 as big. Okay? And now the volume. Again, you take your scale factor, but since it's volume, we're going to raise it to the power of 3. So you have 1/4 times 1/4 times 1/4. 1 times 1 times 1 is 1. 4 times 4 times 4 That's 64. So the volume is going to be 1/64th original size. So here we go, A. Okay? That's all you got to do on those ones. Just surface area, take the scale factor and you square it. Volume, take the scale factor and you cube it. Cubing means raising to the third power. Alright, the dimensions of a triangular prism are multiplied by 0.5. Okay, that's your scale factor. What is true about the surface area and the volume? Okay, they're saying the surface area is going to be multiplied by something and the volume is going to be multiplied by something. Okay, so let's do this. Surface area. Take 0.5 and you square it. So 0.5 squared is 0.25. Volume, you're going to take 0.5 and you're going to cube it. So 0.5 cubed is 0.125. So now we see, okay, 0.10, no, 1, no, 0.25 for surface area. Okay, that's good. Volume 0.125. All right, that's good. So there we go. Okay, next thing here. The similarity ratio of two solids is 2:5. What is the ratio of their areas? Also of their volumes. So the original ratio is 2:5. If we want to do area, we have to do 2 squared to 5 squared. So what is 2 squared? It's 2 times 2, so it's 4. And what is 5 squared? That's 5 times 5, so it's 25. For volume, okay, we have to do the original, but we have to raise them to the third power this time, because it's volume. So what is 2 cubed? 8. And what is 5 cubed? 125. So the areas will be in a ratio of 4:25, and the volumes will be in a ratio of 8:125. So area 4:25, does the volume check out? Yes. So it should be answer choice B. Okay, next one here. It says a triangular prism has a volume of 45 centimeters cubed. If its dimensions are to be made 4 times the original size, what will the new volume be? Okay, all you have to do is take the original, and since we're dealing with volume, we're going to take the scale factor, which is 4, we're going to raise it to the third power. This is going to be 45 times, and then 4 to the third power is 64. So do 45 times 64, and you get 2,880. So that would be the new volume. Okay? All right. There we are with dimensional change. Okay, this is the last little bit. Last tiny bit. These two figures here are called an oblique cylinder and an oblique cone. They're called oblique because they look like they're slanted. They look like they were in a windstorm or something. Got kind of bent over. Don't worry, there's nothing new here. The volume formulas for these is the same as a regular one. So for a cylinder, area of the base times the height. For the cone, 1/3 area of the base times the height. So for both of these, remember the cylinder and the cone, the base is a circle. So the formula that we're using, it's pi r squared, okay? So I'm going to go over here to the cylinder, pi r squared, pi, and we look down here, it's the information they give us. The radius is 4, so 4 squared is going to be 16 pi, because 4 times 4 is 16, okay? And now the height is 5. So my volume is area of the base, so 16 pi times the height, which is 5. So I'm going to have it in terms of pi first, so 16 times 5, so that's 80 pi. If I want to round it to the nearest tenth, I just do 80 times, and then I use the actual pi button on the calculator. It's 251.3. Okay, and then the last thing here, it says, got our cone. Again, be careful here. This 8 inches is the diameter, not the radius. So the radius, we gotta do 8 divided by 2. So it's 4. So you gotta do pi times 4 squared, which comes out to be 16 pi. So now volume, it's 1/3 area of the base, which is 16 pi, times the height. See here, from this picture, the height they're going to tell you is 9. So in my calculator, I'm going to do 1 divided by 3 times 16 times 9. So that's 48, but I did not put the pi in there, so I put 48 pi. And then if I want to round this to the nearest tenth, I do 48 times pi, I get 150, and it's 0.79 on the calculator, so it's going to be 150.8. Okay guys, so that's all there is to it for volume and dimensional change. I know this is a long video, so thank you for hanging in there. Like I said, maybe break it up over a couple days. Do that practice. If you do the practice, it's exactly like the quiz. Alright, I'll see you guys later.